Tons of video tutorials dealing with mobile devices' broken screen replacement are available on YouTube, so it's really easy to find instructions convenient for repairing particular model in home conditions. And that's basically all most of these tutorials can provide. So if you routinely perform service operations on electronic devices with sensitive electronics, they may give you fairly good idea about specific catchers of particular model. If you are, however, dealing with other things in your real life than servicing mobile devices, but still using these technologies on daily basis, possibilities of repairing them probably doesn't concern you until your device breaks down so much it fails to meet desired function and you find out that letting it repair in service center is financially comparable to price of a whole new device. After a little research on the internet, you discover video with instructions for repairing your or similar model at home and everything is fine again. Or not, because it is a quite sensitive process during which many things can be easily screwed up, seriously damaging so far functional parts of the device without you ever noticing that you have done something wrong. Or you just get stuck in a situation about which there was no mention in the video, so you basically don't know what to do next. You proceed exactly according to instructions, only to find out that although screen displays perfectly after assembly, it is completely unresponsive to any touch. Or it responds nicely and you're happy until the moment few days later when it begins to fall apart due to insufficient cleaning of plastic frame from old adhesive remnants. And because these problems can be quite easily prevented, I decided to prepare this comprehensive video guide offering you the opportunity to get a brief insight in mobile devices under the hood functioning, to learn best practices I consider really important for ensuring maximal safety both to your device as well as to your health, and discover a thinking process allowing you to competently evaluate actual situation and choose a suitable technique for solving previously unencountered challenges, which will ultimately lead you to completing repair successfully with tools available to you right now. After watching this rather comprehensive video tutorial, I recommend to watch also some video with instructions for repairing your particular model to get a hunch of its constructional peculiarities. Then, in my opinion, you will be sufficiently equipped with theoretical knowledge for performing actual repairs competently with good chances for making it work again as you desire. So let's get straight into it. Damaged screen can be often reasonably replaced by a functional substitute. A closer look reveals that screen itself is mounted to a plastic frame above which is located a touch sensor often referred to as a digitizer. If your tablet displays normally but does not respond to touch, digitizer is most likely damaged component which can be purchased quite inexpensively from Chinese mobile components manufacturers. It is important, however, to make sure that replacement part is fully compatible with your particular model, especially before placing an order. For performing service intervention, we prepare all necessary tools. These constitute of clean non-metallic working surface, a blunt knife, screwdriver set, latex or nitrile gloves, tweezers, guitar picks, thin plastic cards or hard papers, superfine cleaning cloth and optionally CCD sensor cleansing swab, compressed air in spray bottle or a blower for cleaning camera lenses, in emergency situation improvised by a steep breath from cleansed mouth, working cloth, and a hot air soldering station which may be substituted by an ordinary hairdryer. You may also use protective glasses for additional eye protection. Soft light source such as fluorescent tube or frosted glass light bulb with a color temperature corresponding to sunlight should ensure uniform illumination of work surface with preferably matte finishing. The amount of light should be sufficient for fine mechanical work so you can clearly see what you are actually doing and your eyes will thank you as well. In first step, we remove all hand removable covers, in this case one covering memory and phone card slots. Subsequently, unscrew the screws securing a rear plastic cover with a suitable screwdriver. Lowering unscrewed rear cover along the edge progressively can be performed with thin plastic tool or a blunt knife. We may also secure every major gap with a guitar pick or a thin plastic card. In most cases, however, rear cover should be removable without securing. The tablet in trays are arranged within a plastic frame to which individual modules are mechanically mounted. That largest silvery thing is a battery, and on the right side we can see tablet's camera, microphone and a light source. The most important module here is this blue motherboard, interconnecting and controlling all other modules. Metal heatsink conceals a processor from which control impulses are sent through cables to other modules and individual electronic components such as speakers. Data from sensors are transferred vice versa from peripheries to the processor for digital processing. Green circuit board is a power supply module controlling power supply from the battery to individual components. Knowing all this under the hood stuff will help us replace damaged digitizer in a safe way regarding tablets electronics. How to remove it without damaging underlying screen or any of these important components is going to be discussed in following section. Let's pull out cable that connects touchscreen with tablet's motherboard. Firmly push out securing levers on both sides of the connector slot by tweezers. You can then lift upwards that black elongated flap easily, releasing cable that can be safely removed. A narrow strip at the end of the cable contains metal contacts in the form of small facets. These could be oxidized after many years of use, so we would rub them carefully with a soft wire brush. In this case, they are all in good condition, which we can tell from their appearance as they are really shiny. After peeling off black securing tape, we just pull connecting cable out. Do not throw away the tape itself as it will be used to secure cable of substituting digitizer. And now comes the challenging part. Digitizer adheres peripherally to the plastic frame, so for releasing it, we prepare suitable hot air tool. Hot air soldering station allows not only to connect electronic components for surface mounting precisely to the circuit board, but also remove them by sufficient heating via hot airflow. For its directing, we can use nozzles with different diameters. Goal here is to cover the entire area that should be warmed up, along with minimizing heat stress of its surroundings. The narrow nozzle would sufficiently heat only a gap between digitizer and plastic frame, but since glue is spread on a larger area, around tablets perimeter, in this particular case, we select medium-sized nozzle that will allow us to heat this area conveniently. After switching on soldering station, we need to set hot air's temperature as well as strength of the airflow. The temperature can be specified by arrow buttons. It should be neither too high nor low. If you do not know melting point of adhesive used, it would be appropriate to start at a lower temperature and raise it as needed. Waiting a bit till airgun becomes sufficiently heated and we can proceed with releasing the digitizer. For the same purpose, it is also possible to use an ordinary hairdryer, which, however, covers a much larger area and usually does not allow us to manually set appropriate temperature, but we can compensate that by changing its distance from tablet and performing sideways movements. For liquefying the adhesive, fixing digitizer to plastic frame, we initially warm up the adhesive area around the whole circumference of the tablet. During this stage, we adjust hot air gun's temperature or distance so that adhesive starts melting effectively. Then we focus on one particular place and heat it throughoutly, but not too long to avoid unnecessary thermal stress on plastic frame, as well as other adjacent parts like screen elements. Warmed segment of digitizer can be lifted up by a blunt knife and subsequently secured with suitable thin solid object, such as a guitar pick. We continue by hitting adjacent edge, lifting it up with our cutting tool and securing it with a plastic card or piece of hard paper. If you warm up really long segment, however, adhesive may start solidify in previously warmed part. If that is the case, we can secure currently melted place with a pick, complete heating of remaining part. And after lifting it with knife, secure it with solid plastic card. Keep pushing it firmly into partially solidified segment. Guitar pick picked on our way will help us slit through solidifying adhesive. Then we can take it out, retain for further use, and continue with releasing remaining edges. Long edges should be lightly but consistently warmed up at first. Heating shorter segments more throughoutly afterwards allows us to release them easily with the cutting tool. Knife should never get behind opaque border to the screen itself, as it could mechanically damage screen elements. More advanced releasing technique is based on advancing the knife along a border while heating following segment with hot air. In addition to knife's longitudinal movement, we can further improve it by incorporating brief swishing movements of sharpened part upwards. These get melting adhesive out of the way, making it easier to advance steadily and when encountering a solidified lump, requiring significantly more strength to overcome. Tiny swishes also reduce risk of damaging the tablet by sudden twitch. Securing them frequently with hard paper pieces is a good practice to prevent solidification of previously liquefied segments. It is advisable to proceed with caution near the camera and direct sharp knife edge more upwards towards the digitizer. And as we see, the patient awakened right in the middle of the operation. If you are confident in your skill, release edge you are currently working on and solve the situation after securing it, but under no circumstances continue in work afterwards. Tablet, unfortunately, cannot be turned off at this stage, so we just let its operating system boot up completely, take a break and contemplate for a while about how much are other people lucky that we are not intending to become professional heart surgeons.
Hello, I'm Dr. Stupid. I'm going to take out your liver bones. Oops, you're dead.
If we would continue repairing the tablet while running its operating system, we could cause more damage than good, so do not execute service operations under any circumstances in such situation, but first switch tablet off properly. Although power button invokes a confirmational window asking whether we really want to switch off the device, digitizer does not respond to touch, so pressing the power button again switches tablet to power saving mode, which is similar to administrating only local anesthetics to the patient. We need to realize that digitizer's cable is disconnected, therefore it needs to be inserted into connector slot on the motherboard before interacting with tablet via digitizer. Metal facets of contacts should be facing downwards, and after successful insertion, just tilt down the securing flap. Let's wake up tablet from power saving mode, and if the digitizer still does not respond to touch, it may be necessary to stabilize it first and deliver stronger pressure. Putting our glove off will increase sensitivity in our fingers, but before switching tablet off via digitizer, it is necessary to pull out all objects that may have come under digitizer directly on the screen for avoiding its damage. We are increasing the pressure quite slowly, just until tablet switches off, but surprisingly another window appeared asking for rebooting device into safe mode because the tablet is apparently unhappy with what we are doing to him right now. Confirmatory text is located in broken part of the digitizer, so we manually translocate it into functional one. Even though we may be tempted to smash that piece of electronic junk, just keep your head cool, swing the tablet a little bit, and after confirmatory text reappears in functional part, press cancel, which should invoke another window confirming you really want to switch off the device. But for demonstration purposes here we just confirm reboot, because you may run in situation where switching tablet off via dialog window is not available at all, so then you might be tempted to switch off tablet once and for all. Power button obviously does not react at this time, because after restarting your tablet lives its own life, so just wait until it fully awakes. Finally, now you can shut down tablet completely, but we here just switch it into power saving mode and that's it. The main thing though is that you manage to switch off the screen as well as digitizer. After that, We can continue in service operations, but bear in mind that during power saving mode electronics is still actively working. Therefore, proceeding with extreme caution is essential in order to avoid damaging the tablet irreparably. Let's warm up remaining edge of the tablet. Heating third edge more thoroughly and lift it up with knife while reheating stiffer parts. After securing it with hard paper, we advance to last section. Border area here is larger, and as more adhesive requires more heat, heating can take longer time, but increasing temperature of hot air tool slightly might help us as well. Touching the largest possible area of the edge at once can be realized by hitting it from the end towards last securing object. The closer, the slower our movement should be. On hard paper, we can easily mark the depth from tablet's edge to the screen measured either by a ruler or our own eyes after placing paper into that area. At the end, we can slightly warm tablet's edge around whole perimeter to melt resolidified places, allowing safe removal of digitizer. But first, we have to disconnect its cables from the motherboard. Push out securing levers on both sides of the connector slot by tweezers and lift elongated flap upwards so that cable can be subsequently removed. Bear in mind that the whole device is just in power saving mode, so we should proceed cautiously to prevent touching electronics or metal components with our fingers. Extraordinary caution should be kept when working with metal tools, so in no way they may come in contact with electronic components which are under voltage at the moment. It's worth mentioning that this paper hides digitizer cable extending through opening in the plastic frame. Then we can finally hit re-adhering edges. Cut through with cutting tool and put damaged digitizer aside or throw it away. We can now clearly see irregularly distributed adhesive residues all over digitizer's border, but they have remained also on plastic frame of the tablet, from where we should remove them. So border of a new digitizer can tightly fit to the frame and adhere to it with as large surface area as possible, undisturbed by any old lamps. First, let's remove all securing objects adhering to the frame. Then, gently warm adhesive residues and pull them out of the frame surface with tweezers. Visual inspection should ensure that frame is now really clean. Any remaining residues can be removed in the same way as previous ones. Before installing new digitizer, we need to clean screen surface as well as plastic frame of tablet. To achieve this, we can use three approaches. Airflow is good for removing tiny dust particles, but probably will not handle smudged and dirty places. If we don't have any airflow source except our breath, it is possible to use a superfine cloth. Carefully sweep dust particles off the surface, but bear in mind that excessively coarse fibers or high pressure may create scratches on the screen. Therefore, choosing appropriate cloth and proceeding with caution is essential when removing them this way. More gentle dust sweeping and stain removal can be achieved with a cotton swab for cleaning camera CCD sensors. The thing is usually sealed to maintain purity and retain cleaning solution infused into the swab moisturized. We could sweep whole screen with it line by line, but let's put the swab back and focus on airflow variant. In home conditions, We can get airflow freely by an ordinary hairdryer. Higher fan speeds are favorable as well as disabled heating for this purpose. We can gradually blow away tiny particles, preferably from the center toward edges. For a more thorough cleaning though, convenient tool is compressed air that allows us to blow away bigger or more strongly attached particles, not only from the screen but also from plastic frame itself. It is usually an elongated tin container that needs to be shaken before use, and although we could blow dirt right away then, good practice now is testing strength of the airflow and selecting appropriate distance from tablet so the flow is just enough to blow away majority of the particles. In the second stage, we use a cotton swab to remove dirt adhering to the surface, left untouched by airflow. With a slight but firm pressure, keep dragging the swab from left edge to the right. Small screens or large smudged areas can be thoroughly swept line by line. In every following line, we also sweep a bit of the previous one to ensure cleaning whole surface area. For large screens or relatively clean ones with very few dirty places, moisten them by touching with cotton swab and let cleaning solution chemically react to dirt for a while, then just remove stain by touching it again with soft, highly absorbent material such as a facial cotton swab. Faster but less safe option is simply smearing smudge over a larger area and wiping it off by superfine cloth. Moistening with a cleaning solution followed by a short pause and subsequent smearing and swabbing off will help us to eliminate even relatively stubborn stains. The new digitizer from a Chinese manufacturer of electronic components has two sides. That smooth and nice looking surface border represents top side, whereas written cardboard protects the layer of fresh adhesive on backside, which we clean from dust particles by airflow or soft cloth. Placing digitizer to the screen subsequently allows us to make sure that backside border with adhesive layer is dimensionally identical to the corresponding region of plastic frame. Digitizer's cable should get easily through the opening in plastic frame. We can remove a protective sheet from backside by pulling it off manually, but use tweezers for cardboard concealing adhesive layer. Increased caution should be taken near cable. Lift it up by freehand so cardboard can easily pass around without tearing itself apart. During this process, try not to touch uncovered parts to avoid contamination and damage of the adhesive layer. Stability can be ensured by pressing outer protective sheet of digitizer to the work surface. We have an uncovered fresh adhesive layer all around periphery, allowing digitizer adhere tightly to plastic frame of the tablet. Let's move the whole thing slightly over the edge of our working table so that under frame opening is nothing but a gaping hole, ensuring free movement to digitizer's cable. Performing final dust particle removal from the surface of the tablet now is an important step, as all mist dirt would remain there forever, deteriorating screen's readability or even damaging it mechanically. So check carefully surface cleanliness and make sure all visible dirt is gone. We can also slightly clean digitizer's backside by airflow. Let's start assembly by moving digitizer slowly towards the screen, letting cable naturally pass through opening in the frame. Adding little movements from side to side may help passing it smoothly. Move tablet back on the work surface to provide more stability during assembly. Measure backside edges of digitizer with your own eyes so that they precisely correspond to tablet screen edges. Start laying down digitizer slowly, and with each currently laid edge segment, press corners for their temporary fixation. Secure 3 corners this way. The last one, near the cable, you can let free at a time for tighter gluing overall, or fix it as well for more accurate edge alignment. We can glue all fixed corners by reasonably intensive pressure using our fingers and then proceed with gluing individual edges. Push only regions overlying plastic frame border to avoid damaging screen mechanically. In cable's vicinity may occur considerable bulge, which can be removed by pulling the cable downwards while pushing down adjacent region of digitizer's edge, thereby gluing it throughoutly to the plastic frame. At last, we would also glue the fourth corner if we would have kept it free before. The most important part is now successfully completed, so let's make tablet fully operational. Before connecting the digitizer's cable to the motherboard, we should clean electronics first. If using a cloth, there is an increased risk of damaging sensitive components by electrostatic discharge, so utilizing airflow may be more convenient. The cloth is quite suitable for large cooling surfaces though, along with tablet's plastic frame and cables. Lift up black securing tape by tweezers, then gently but firmly plug digitizer's cable into the socket. Tilt down elongated flap, snap locking levers, and secure cable with tape against arbitrary motion. During this stage, we are very careful to avoid direct contact with tiny electronic components, touching them as little as possible. Digitizer is now mechanically attached to the tablet's plastic frame and electronically connected to the motherboard, so the information about finger pressure on digitizer should be properly transferred through cable for further processing. Assembly could be completed by returning rear plastic cover back to its place, but we do not do it yet. Instead, let's check that everything actually works as expected. We switch tablet on with power button to determine whether it responds at all. The moment of truth. Great! Taking off a glove can help us get better sensitivity in fingers for performing more precise examination. Control elements on the screen should react to even slight pressure, like the original digitizer did. Similarly, sliding your finger across the screen should produce expected shift of displayed content. Let's step up with checking appropriate response of different regions, for which we can use launching individual applications. Subsequent testing should verify proper response in small, closely adjacent items, which can be done in any application using touchscreen keypad. For this rather brief verification, our fingers are sufficient, but more accurate testing would require a touch pen or similar object. This last test should also be performed after finishing whole assembly, because tablet may seem to respond slightly inaccurately if rear cover includes additional shielding for electronics or your working surface is not perfectly insulating. If such inaccuracies persist after mounting rear cover, double check that digitizer's cable contacts are in good shape and properly plugged into connector socket. When checking is finished, we can safely switch the tablet off. Mechanical buttons should react the way we are used to. If they suddenly require much higher pressure or special handling, their caps might have been shifted during repair, so we will fix their position in a minute. Let's begin mounting of covering elements by cleaning inner side of the rear plastic cover with an airflow or a soft cloth. Tablet's electronics should be also cleaned lightly. Checking visually button cap with its corresponding contact element on the motherboard helps us to reveal if they are not aligned precisely. In that case, use tweezers to move button caps on center of corresponding contacts. When pressed by a finger, button's position should optimally transfer finger's pressure to its contact element. If there are more buttons mechanically coupled together, as here in the case of volume control ones, centering them all may require more time. Before putting back any constructional component, it is good practice to reasonably clean adjacent parts even though we've cleaned them before. At glance, we make sure that everything is in its place and nothing prevents mounting of the rear cover. After snapping its corners by slight pressure on the edges, cover's little latches should snap in all around the perimeter. If, in some places, you haven't felt any snapping, you can help them with a thin screwdriver or, more gently, with hard plastic guitar pick. perfect snapping of imperfectly snapped latches can be achieved by pushing edges from the tablet front side and eventually few areas around outer surface of the rear cover. It is also necessary to screw the cover at 3 places, in this case near slots for memory and phone cards. Watchmaker screwdrivers from ferromagnetic material are quite handy tool, as they allow mounting tiny screws really easily. Then we can put on cover for insertable cards. Finally, dust off the tablet and clean it reasonably at your own consideration. Peeling off a protective sheet will expose digitizer surface that is screened from a factory, and we are done. If you are repairing tablet for some other person, leave the protective sheet on screen and peel it off just before you hand over the device to the owner. That way, digitizer surface remains intact in perfect condition without any unnecessary smudges and scratches. To be sure it works correctly, we can perform a final functionality test. And it is an Android, so turning it on takes a little bit longer. We see it booted up eventually, so let's get it done. Digitizer responds primarily to finger pressure, so gloves on our hands should make no difference to tablet's response at all. In the case of a capacitive screen though, it would be necessary to take the gloves off. We can clearly see that digitizer responds correctly to fingers sliding across the screen, allowing us to cross-check only a few things. At first glance, we do not see any defective pixels, which is a really good sign. Some features may take a little bit extra time until they respond to tactile stimulus, so in that case, just wait. As can be seen, increasing the screen brightness was indeed successful. Now would be perfect time for performing in-depth testing to verify proper response in small, closely adjacent areas by, for example, typing letters via virtual keypad. Last thing we check is the physical button's response. Tablet can be switched off smoothly, and we have verified that everything actually works as it should, so you can start using it with a pleasant feeling coming from job really well done. So, thank you for your attention, and I personally hope you find this video guide helping you to successfully repair a damaged screen of mobile device, avoid common mistakes along with causing unnecessary damage, and enhance your understanding of these devices. So whereas you would previously found yourself completely desperate during service intervention, now you are able to competently evaluate your actual situation and find the most suitable way for successfully completing whole operation. See ya next time!